Hello friends, welcome to BD Path channel. So this is my first video about hematoxylin and eosin stain. Before starting about the stain, what is histological stain? Histological staining is used to highlight important features of the tissue as well as to differentiate structural elements of the tissue by their color and or staining intensity. They are classified into two categories. One is routine staining and another is special staining. In the histopathology laboratory, the term routine staining refers to the hematoxylin and eosin stain, which is known as HNE, that is used routinely with all tissue specimens to reveal the underlying tissue structure and conditions. The term special stain has long been used to refer the numerous alternative staining techniques that are used when the H&E does not provide all the information the pathologist or researcher needs. Now, what is hematoxylin? Hematoxylin is a natural dye derived from the hardwood of the Hematoxylum campesинum tree, which is basically a logwood. Now, Hematoxylum campesинum is a species of flowering tree in the legume family, which is Fabaceae, that is native to southern Mexico and introduced to Caribbean, northern Central America and other localities around the world. This plant is still used as a source of the histological stain hematoxylin. The plant is also used in certain traditional systems of medicine. Now, what is eosin? Eosin is the name of several fluorescent acidic compounds which bind to and form salts with basic or eosinophilic compounds like proteins containing amino acid residues such as arginine and lysine, and stains them dark red or pink as a result of the actions of bromine on eosin. In addition to staining proteins in the cytoplasm, it can be used to stain collagen and muscle fibers for examination under the microscope. Structures that stain readily with eosin are termed eosinophilic. In the field of histology, eosin Y is the form of eosin used most often as a histologic stain. Now, what is the principle of hematoxylin and eosin stain? The H&E stain provides a comprehensive picture of the microanatomy of organs and tissues. Hematoxylin precisely stains nuclear components, including heterochromatin and nucleoli, while eosin stains cytoplasmic components, including collagen and elastic fibers, muscle fibers, and red blood cells. The chemistry of H&E stain. Basically, staining does not produce color randomly. Instead, the dyes exploit differences the chemistry of the tissue to differentially dye various components. Hematoxylin is positively charged and binds with negatively charged cell components such as nucleic acid in the nucleus. This stain blue as a result. In eosin is negatively charged and can react with positively charged cell component in the tissue such as amino groups in proteins in the cytoplasm. These stain shades of red to pink as a result. So here you can see this is alum hematoxylin, sorry. This is alum, extremely sorry. Okay, so this is known as alum hematoxylin. It's bind with negatively charged compound, and this is eosin. It combined with positively charged. So the staining procedure for hematoxylin He, first of all dewaxing, then dehydration, then hematoxylin, then differentiation, then bluing, then eosine, then dehydration, then clearing, and at the end cover slipping. So staining preparation, Harris hematoxylin we are basically used most commonly. So composition, hematoxylin quantity 2.5 gram, absolute alcohol 25 ml, potassium alum as a mordant 50 gram, distilled water 500 ml, mercury oxide 1.25 gram, or sodium iodide oxidizing agent 0.5 gram. And glacial acetic acid is optional, which can be used or not. It is 20 ml. Now the staining preparation, 1% eosine Y 1 gram, distilled water in 100 ml, glacial acetic acid 1 to 2 drops. And how to ready 1% acid alcohol, HCl 1 ml, concentrated HCl 1 ml, and 70% alcohol 99 ml. Now the method of staining, deparaffinage the sections in xylene 10 to 20 minutes, then rehydrate the sections, 100% alcohol or absolute alcohol for 1 to 2 minutes, 95% alcohol for 1 to 2 minutes, then rinse in tap water, then rinse in distilled water, then stain with hematoxylin for 3 to 5 minutes, then wash in tap water. Differentiate sections with 1% HCl in 70% alcohol, 1 to 2 dips, and check under the microscope. If necessary, return slides to acid alcohol solution for further differentiation. Then wash slides in running tap water for 15 minutes or use 1 to 2 dips lithium carbonate or ammonia solution for bluing. Stain slides in eosine for 1 minute. Dehydration and differentiation, 95% alcohol 5 to 6 dips, 100% alcohol or absolute alcohol 5 to 6 dips. Clear the slides in xylene with 2 times, xylene 1 and xylene 2 for 2 to 3 minutes. Then mount the slides with mounting media. So this is the method of staining. So the result, nuclei is to be black or blue, cytoplasm colors varying shades of pink, muscle fibers deep pink or red, RBC orange or red, and 15 deep pink. So this is the picture of proper hematoxylin eosine stain. Here the hematoxylin, which gives the blue color in the nucleus, and the eosine gives the pink color to the cytoplasm and other. So this is a perfect example of hematoxylin eosine stain this picture shows. So this is the unstained tissue to stained tissue, means unstained tissue to the hematoxylin eosine tissue. Here we can see, and this is figure 1. This is a clear picture of hematoxylin eosine stain, figure 1, and figure 2, colon tissue shows a clear picture of hematoxylin eosine stain. Figure 3, this is basically a skin tissue. So here you can see the balanced coloration in the section of skin. The nuclei are stained purple while the cytoplasmic components are pink. So my question to the listener at the end of my slide, what is bluing and why tap water is used in hematoxylin eosine stain? And another question, that we used hematoxylin, so hematoxylin is a progressive staining or regressive staining? So if you interested in this video, in this type of videos, so please subscribe, like and comments. and my next video